depending on where you are today. Before I start, just some points of housekeeping. In the handouts box, you will see that we've included a copy of today's presentation for you to download. We've also included a copy of a Vision Zero paper, which was written by our head of profession in Patey. There will be an opportunity to ask questions at the end of today's session as well. So thank you very much for joining today's webinar. I'm Simon Sheldon Wilson. I head up the operations and safety business within WSP here in the UK. Operations and safety is one of three businesses that make up the ITS discipline for WSP UK that sits alongside our lighting and energy business and our systems and infrastructure business. My career has been spent in roads and transport related roles, from roadside assistance operations for a number of years through to leading real-time traffic operations, incident response and customer information services for the high-speed road network for England. My work has allowed me to experience closely the challenges of operating high-speed roads and the incidents that occur on these types of roads. And that's made me a passionate advocate of improving road safety. So today's webinar discusses something that is important to me personally, and I think as industry professionals and as caring human beings, something that's important to all of us. And that is how we deliver a transport network that enables livelihoods, but that does not cost lives. So the agenda for today, over the next 20 minutes or so, we'll spend a little bit of time talking about the context for Vision Zero. I'll share with you the ITS whole system approach to delivering on the Vision Zero ambitions. We'll talk about the contribution to the UN Sustainable Development Goals. I want to share with you an example of how we apply the ITS whole system approach to developing the UK motorway capacity and operation. Finally, we'll have some key takeaways at the end of the presentation, and then, as I mentioned previously, there will be an opportunity for you to note some questions, and I'll be able to answer them, or any comments or other thoughts that you might wish to share. Now, before we start, I would like to spend just a few moments to reflect on the enormity and the importance of the challenge that we as professionals across the transport community face. On average, some 1.35 million people are killed on the world's roads every year. That's almost 3 people every single minute. Road deaths are the #1 killer of young adults and children across the world in the age group 5 to 29. And more than half of those killed are vulnerable road users. That's pedestrians, those on bicycles, mopeds, scooters, and motorcycles. In addition to the tragic loss of life, it is estimated that between 20 million and 50 million people are also seriously injured on the world's roads each year. So that means that during our 30 minutes or so together today, on average between 75 and 90 people will not be going home to their families. Now, as many of you will know, Vision Zero is not new. In the 1990s, the Swedish government recognised the huge loss of life from transport, and they set in place ambitious plans to reduce and then eliminate the loss of life from road transport activities. Since then, the concept of Vision Zero has been adopted across Europe and is now gaining recognition across the world. Acceptance of Vision Zero requires a complete shift in thinking in everyone involved in designing, operating, maintaining, and using road transport. That shift in thinking is shown in this simple table, illustrating in the center column there the traditional approach to road safety, and in the right-hand column, the Vision Zero approach. Now, to put it simply, road deaths and serious injuries do not have to be accepted consequences of mobility. They are preventable. But to achieve that, we need road users and designers to share responsibility. And we need to accept that humans are humans and will make mistakes. Achieving our collective ambition to Vision Zero will not come from tackling any one aspect of road transport in isolation. The ecosystem involved in road transport, people, vehicles, infrastructure is deeply interwoven and too complex. Instead, we will achieve a continuous drive towards Vision Zero from an ITS perspective by taking a whole system approach, where ITS can play a vital role as illustrated by this model. This whole system approach recognises that road users and system designers, and by that we mean politicians and governments, infrastructure owners and operators, vehicle manufacturers, transport planners, engineers and road designers, care providers, enforcement bodies, and many others, are all responsible for the existence of a safe system. But what does that mean in practice? Well, it means that road users should adhere to the regulations, but we know that they will make mistakes, and designers must therefore plan, design, implement, operate, and maintain systems that take into account human error. Such an approach engenders a holistic view of system interdependencies. It recognises and aims to prevent a scenario of implementing a beneficial solution in one aspect that can have detrimental impacts elsewhere. Let's have a little more detailed look at this ITS whole system model. The interaction and interdependencies that exist between people, spaces, and vehicles all take place within the context of an evidence-based road safety management system. A formal and comprehensive assessment framework, as developed by WSP for national highways, is integral to the whole system perspective. This approach enables the safety implications of any proposed change to be evaluated prior to implementation using existing qualitative and quantitative data. The predicted outcome is validated when in operation, and that allows ongoing refinement of the assessment methodology. As we all know, road transport schemes are integral to the form and function of communities. They connect people to places, they enable the movement of goods, and they support commerce and economic growth. But the users of those road systems are diverse, each with their own needs, each with their own vulnerabilities. The whole system approach considers all users, all modes of transport, and all places where road transport activity occurs. As humans, we acquire information from the world around us. We interpret that information and we make sense of it, and then we respond in our own unique ways. Factors that affect individuals and cause them to respond the way they do are many and varied, causing people to react in unexpected and sometimes irrational ways. By understanding this, we can help designers to encourage user compliance and reduce human error. The next great leap in vehicle safety is to reduce the impact of human error, and that's likely to be through connected and autonomous vehicle technology. Now, level 1 and some level 2 technologies such as autonomous emergency braking and lane keep systems have already commenced that journey, and there is now greater understanding and correlation and coordination between vehicle manufacturers and infrastructure owners and operators. Understanding why and how severe crashes have happened is vital in preventing more deaths and serious injuries on our road. Using a safe system approach means using learning from crashes to resolve issues everywhere, not just at the location where the crash happens. And this differs from the historic focus, which has been on improving crash hotspots rather than understanding the incident in the widest context. Now, at WSP, we aim to ensure that our projects align with the UN Sustainable Development Goals that you can see on the screen there. And our whole system approach to ITS and its contribution to the Vision Zero safe system demonstrates our commitment to delivering the UN goal of good health and well-being. Through our work on the UK motorway schemes, and we'll look at some examples shortly, we've delivered health, safety and environmental benefits when delivered and measured against the baseline. Just some examples, on one measured scheme, we saw a 50% reduction in personal injury rate, a 30% reduction in noise, and a 7.5% reduction in harmful pollutants. The WSP ITS whole system has been fundamental in delivering a Vision Zero safe systems approach to modernising the high-speed road network in England. The approach that we've taken has been demonstrated across a range of developments to the way the high-speed road network is operated, starting with controlled motorways through to active traffic management and now all lane running sections, with the origins of these developments dating back to the late 1990s. The high-speed road network in England is operated and maintained by National Highways and covers some 4,000 miles of motorway or freeway and dual carriageway trunk roads. Now, whilst that 4,300 miles of roads accounts for just 2% of the overall road traffic in England, it carries 1/3 of all road traffic. 2% of the overall road network in England, it carries 1/3 of all road traffic and 2/3 of the country's freight traffic movements. Developments to the high-speed road network have been made with the objectives to make better use of existing road space, to relieve congestion, and to improve journey time reliability, and to do all those things in a way that maintained a safe road network environment for road users and operators. Taking a whole system view has been fundamental, and this commenced with a pioneering approach with a comprehensive assessment framework. A detailed hazard log was created which identified some 150 hazards, and those were scored to identify the highest risks and areas of greatest priority. By understanding this safety risk assessment, designers were able to shift focus from the technology and consider properly the user behaviours that were identified. These were in particular excess speed in relation to the conditions, poor lane discipline, and travelling too close to the vehicle in front. One aspect of the changes to the high-speed road network was the creation of a new environment which introduced the concept of a dynamic road environment for the first time in the UK. Both the available road space and the speed limit were made variable, and this required the road operator to provide real-time, understandable information and for users to interpret that information and act accordingly and appropriately. Using traffic signs and signals provided clear indications to road users of both the lane availability across all lanes and of the speed limit. And this speed limit was automatically reduced when the hard shoulder emergency reserve was made available as a running lane. The operations centre could then apply further speed restrictions in response to traffic conditions, weather conditions, or incidents. Creating the environment in a way which addressed the hazards and risks from the safety risk assessment meant assuring that the space, the highway, was being used safely. Key to this is the need to set speeds that reflect the prevailing conditions, either the opening of additional road space, as we just talked about, or in response to incidents, roadside activity, or weather conditions. Those speed limits, alongside supporting information through pictorial or text messages, are key to informing road users and in delivering the anticipated benefits of the development. Of course, setting the speed limit is only one part of the safe space equation. The other is in providing an enforcement regime and or the perception of enforcement to deliver a level of compliance with the speed limits that will create the safe space. Recognising a fundamental of Vision Zero, and that is that road users are human and will make mistakes, also meant designing the road infrastructure in a way that is forgiving of error and protects vehicle occupants. This means careful consideration in positioning roadside infrastructure, indeed questioning the need for that roadside infrastructure, safety barriers that eliminate the possibility of vehicles crossing between carriageways, and roadside barriers that absorb impact and eliminate the possibility of moving vehicles coming into contact with large fixed installations. And prompt response to incidents and treatment of casualties is a fundamental tenet of the safe systems approach. Responding promptly has two key aspects. Firstly, the ability to get emergency responders, for example, police, ambulance, and fire and rescue, to the incident location. Doing so enables the scene to be protected, reducing the risk of further incident. In the case of minor incidents, for example, a non-injury collision, debris in the roadway, or breakdowns, for example, rapid clearance reduces the risk of secondary incidents involving slowing or queued traffic. Secondly, and in more serious incidents, getting casualties from vehicles and providing treatment can commence as soon as emergency responders arrive on scene. And we know this increases the chance of survival for those that have been seriously injured in road accidents. The system now used on the English motorway network considered these points and in a holistic approach engaged with the emergency responders and the highway operator's own traffic officer service to develop clear operational procedures. These included providing and using emergency access lanes and reverse flow incident approaches to enable emergency vehicles to access the scene by running against the direction of travel for that carriageway. In taking this whole system approach to the design and operation of the high-speed road network, using one particular measured section as an example, we've been able to demonstrate some significant benefits. Journey time on the sections that were measured reduced by 26%. As we mentioned earlier, personal injury rate reduced by 50%. Overall, 80% of the benefit was delivered for 20% of the cost when compared to a traditional scheme to widen the motorway. There was a 4% recorded reduction in fuel consumption, 30% reduction in noise levels, and a 7.5% reduction in harmful pollutants. Now, we continue to work with the operator of the high-speed road network in England and continue to further develop the whole system approach to encompass alternative methods for operating the motorway network and also exploring how we do that on non-motorway high-speed roads. Now, the UN has set an ambitious target, and that's to reduce global road deaths by 50% by the end of this decade. The Vision Zero safe system approach recognises that achieving that ambition requires action around multimodal transport, land use planning, safe road infrastructure, safe vehicles, safe road use, and post-crash response. It means a shared responsibility between system designers and road users. As we've discussed, the ITS whole system approach supports Vision Zero through expanding beyond ITS technology projects and into key areas that, delivered together, can deliver a safe road network for all. By taking a whole system approach, we can ensure that one aspect of the road transport ecosystem isn't improved to the detriment of another. And that means we can all play a fundamental part in delivering Vision Zero, and we can ensure that more people go home to their families at the end of each day.
Thank you, Simon, for a fantastic presentation.
Thank you very much.
So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download the PDF version of this presentation from the handout box on the dashboard, along with the recent article, paper by Ian Patey about Vision Zero and ITS. So I will start with the first question. What further innovation do you see being developed to support the safe operations of the UK high-speed road network?
Thank you. I think technology innovation will come in two areas, and already we're seeing that. So National Highways have a program at the moment of installing radar systems on some parts of the network to detect stopped vehicles on the network and allow them to respond more promptly to those to get them moved away from the scene. So I think some of the technology innovation will come from developing infrastructure that supports the operation of the road network. But as I mentioned in the presentation, there is now greater collaboration between vehicle manufacturers and highway operators. And I think with connected and autonomous vehicle technology, that there will be a significant shift towards the intelligence being within the vehicle and being able to respond to the environment it finds itself in, sharing that information about the environment it finds itself in with other vehicles in proximity. And of course, those driver aids that we will see that are available now on some vehicles that will help to improve driver safety. So I think there is a clear benefit in the move to connected and autonomous vehicles in helping to address the immediate risk that humans and will make mistakes, and technology will help to address that. But of course, that will take time to happen.
Thank you. There's a question here about slide 17 about the benefits. Are we seeing similar results for all lane running sections of motorways?
Yeah, those who are close will be aware of some of the interest in all lane running, and there's some detailed work that we've done around all lane running sections of motorway. That's the latest standard that's being applied. It's an ongoing exercise to continue to evaluate those sections of motorway. I think what's really important within those as well is just understanding driver behaviour. Quite often we focus on technology and how we deploy that. I think driver education and driver behaviour continues to be a really important part of ensuring the benefits and the safe operation of the road networks that we develop. And all lane running sections of motorway for particular reasons are an area of real focus at present, and we continue to do a lot of work to support the evidence for the operation of those types of roads.
Thank you. There is a comment here and some questions. Given what you said about human error and road space having to be designed in such a way that takes error and human tolerance of crashes into account, should we not reinstate the hard shoulders, or should we be looking to other solutions like in-vehicle technology?
Okay, I think it's a very good question, and I think very often there's an assumption and phrases that use that the hard shoulder is a safe space. And I know from my own personal experience of the roles that I've done previously that isn't the case, and the data supports that in terms of the number of accidents that or killed and seriously injured people from the hard shoulder. If there's a hard shoulder there, people historically have chosen to stop on the hard shoulder, perhaps for non-emergency reasons. So to read a map historically, maybe more recently to set the sat nav or use a telephone or take the children to the toilet or whatever it might be, and that represents a significant hazard to them and to others, and risk of accidents and injury. So I think it's not fair to assume that just by having a hard shoulder you make the environment safe again. Taking away the hard shoulder using all lane running is applicable to certain areas of the network where there's congestion and challenges, and as I mentioned earlier, we continue to work to look at the evidence and to provide evidence that supports the design of the motorway, and not respond necessarily to it's not our position or place to respond to media on that particular point. We have the evidence and we work with our clients on that basis.
Thank you. The next question is about public perception. Is political or evidence-based support for smart motorways developed enough to deal with poor public perception?
I think the evidence is developed enough. I think the challenge is how road operators and perhaps politicians deal with that in terms of sharing that in a way that the public understand. I say we've worked on these schemes for numbers of years with significant body of evidence supports the approach that in terms of the safety assessments, and I think it's important to find ways to help to educate road users both in how they should safely use these types of roads and in the overall safety benefit that these roads bring. Now, clearly, any incident where someone is killed or seriously injured on any road, and that includes smart motorways and others, is something that none of us want to see, and we should always be looking for ways to help people understand and help to design out, continue to design out and learn from and design out those things that represent hazards for road users to continue to improve safety.
Thank you. Is any one aspect of the ITS whole system more important than the others?
It's a very good question. I think by its very nature as a whole system, the principle of that is that all of these things are balanced and equally important. And one of the challenges I think historically has been doing something which seemed to be the right thing, perhaps without fully understanding the implications elsewhere, and that led to an improvement in one area of road safety, but some negative impacts elsewhere. And the whole system approach seeks to address that by looking at things in the round. I think you could argue that the safety assessment is probably could be argued is the most important if you properly understand through the hazard log the hazards and the risks and the mitigation and the approach to be taken, then that actually informs the other things that you can do around that wheel. So whilst I would argue that they are all equally important, I think having good evidence to understand what you're doing and why, and being able to measure the benefits that you thought you would get, any unintended consequences, and continue to develop the hazard log probably could be argued slightly more important.
Thank you. Given the time, I will just take the last question. This is about connected and autonomous vehicles. How do you think connected and autonomous vehicles will change things?
I think this is the next kind of big change that we will see. As I mentioned in the presentation, some of that technology is already in vehicles. Now, some of it can't be used at the moment on certain roads in the UK, but there are things like autonomous emergency braking and lane keep systems and other things that are part of the connected or move toward connected autonomous vehicles. I think as those things become more commonplace across the range of vehicles, across the vehicle park, and as the vehicle park changes over time and more modern vehicles take to the roads, we will start to see more of the benefits of these types of vehicles. But this doesn't happen overnight, and in the meantime, we have to continue to work to design roads which are safe with the types and mix of vehicles that we have. But certainly the thing I'm looking forward to next in terms of a step change in safety for everyone is connected and autonomous vehicles. And along the journey to that is the continued improvement in driver assistance systems that will get us there.
Thank you. Thank you, Simon, for a fantastic presentation. So we're at the end of our webinar session. Please feel free to follow up directly with Simon via the contact details shown on the screen. Thank you, everyone, for joining today. Thank you, Simon.
Thank you very much. Thank you.